So we turn now to case study 7.4, and the issue that we're going to look at is to take the well-known lead-acid battery that's in every car that isn't all electric, and that lead-acid battery starts the gasoline or diesel engine. And so it's a very central part of our life, and we have experience with it because sometimes they go dead. And why do they go dead? And the other thing is that they're very sensitive to temperature. So if the battery isn't in top shape and it's a very cold morning, it doesn't supply the sufficient voltage to turn the starter motor over that then starts the gasoline or diesel engine. So it's a common piece of experience that we've all dealt with, but it brings together electrochemistry, but not just electrochemistry in isolation. It brings electrochemistry in under non-standard conditions. And it's the ability of electrochemistry to deal with the non-standard conditions that makes this case study so intriguing. But it also draws us into acid-base reactions and also oxidation reduction processes. And so we looked at acid-base reactions in Chapter 6. We did the oxidation reduction processes in Chapter 2, and of course electrochemistry in Chapter 7. In addition to electrochemistry, acid-base reactions, and oxidation reduction processes, there's a really interesting piece of history tied in to the lead-acid battery. And that history revolves around two very famous people, Thomas Edison and Henry Ford. And the remarkable thing about the relationship between these two is that Thomas Edison developed the electric light bulb in 1879, but in 1884 he began developing techniques to generate large amounts of electrical energy because he wanted to electrify, first of all, the urban areas and then the rural areas. But the interesting connection is that Henry Ford, as a young man, worked for Thomas Edison, worked in his laboratory. And as Thomas Edison began to develop more and more sophisticated ways of storing energy, in particular, he was interested by the late 1890s of developing batteries for electric cars, because Thomas Edison realized that the electric motor was 95% efficient, whereas the gasoline engine converted only about 15 to 20% of the chemical energy and fuel into work. And so Thomas Edison realized that if you have a very clean automobile that operates smoothly and quietly on electrical energy, it's vastly superior to a gasoline car that is not only noisy and at that time very rough, but it was a much lower quality of transportation. But in 1908, Henry Ford came out with a famous Model T, which is shown here. And that Model T began to sell very large numbers of automobiles. And so Thomas Edison came out with his electric car just a little bit after Henry Ford, but the gasoline automobile took over the market. And interestingly, it was 4 years later, in 1912, that Henry Ford put in the electric starter, which was driven by none other than the lead-acid battery. And this solved two problems. One, it made starting the engine very easy, but it also took away a hazard that was intrinsic to cranking a gasoline engine, because as we studied in the thermodynamics of heat engines, the gasoline engine is set to fire the spark in the spark plug just as the piston reaches top dead center. And so when the explosion takes place of the mixture of gas and air, it drives the piston down and it runs smoothly. But if that is slightly mistimed and it fires as the piston's coming up, then it instantly rotates the crankshaft in the opposite direction. And when you're cranking it with your arm, this created a huge number of, let's say, accidents that basically were broken arms. So the lead-acid battery was very, very important to the evolution of the gas car. Now, since 1908, there have been millions of person hours, tens of millions of person hours, going into refining the gasoline engine. If that same effort had gone into developing the electrochemistry of batteries, we would all be driving electric cars now. So it's very interesting to see how the transportation sector bifurcated and the gasoline engine took over automobiles and took over the market.